We are considering force and types of forces. Force is a push or a pull. Force is a push or a pull. And there are some laws that back up the definition of force or that explain what force is. We'll be looking at Newton's first law of motion. Newton's first law of motion that states that a body will remain at rest or continue to move with uniform speed along a straight line unless acted upon by force. I repeat, Newton's first law of motion states that a body will remain at rest or continue to move with uniform speed along a straight line unless acted upon by force. And the tendency of a body at rest to move or for a moving body to stop is called inertia. The tendency for a body at rest to move or for a moving body to stop is called inertia. Force is a vector quantity and the SI unit is Newton. Force is a vector quantity and the SI unit is Newton. Now let's look at some other the types of force that we have. Weights. So the force which tends to pull a body towards the center of the earth is the weight of the body. The force which tends to pull a body towards the center of the earth is the weight of the body. And a body of mass m has weight which is called, the weight will be mass times the gravity. And g is the acceleration of a free fall due to gravity. So the mass times the gravity will give us the weight of the body. Number 2, electrostatic force. Electrostatic force. This is the force that acts between electrical charges. This is the force that acts between electrical charges. There exist two types of charges. We have the positive and the negative charges. It is found that like charges repel, but unlike charges attract each other. I repeat, electrostatic force. This is the force that attracts that acts between electrical charges. We have two types of charges, the positive and negative charges. It is found that like charges repel, while unlike charges attract. Number 3 is the nuclear force. Nuclear force. In the nucleus of an atom, there exists a strong attractive force, which is neither gravitational nor electrical. This force, which holds together the proton and the neutron that makes up the nucleus, is referred to as the nuclear force. In the nucleus of an atom, there exists a strong attractive force, which is neither gravitational nor electrical. This force, which holds together the protons and the neutrons that makes up the nucleus, is referred to as the nuclear force. If this force were not present, the electrostatic force of repulsion between the proton, which carry positive electrical charge, would cause the nucleus to disintegrate. Number 4 is the tension. Whenever two parts of a body are being pulled away from each other, that body is under tension. Whenever two parts of a body are being pulled away from each other, that body is under tension. For example, the string of a simple pendulum and the string of a spring balance under use. So they are under tension. Body under tension usually stretch a little as the tension increases, and they return to their original length when the tension is removed. Body under tension usually stretch a little as the tension increases, and they return to their original length when the tension is removed. So they return to the original length when the tension is removed, provided the tension is not too large. This property of regaining the original length is known as elasticity. I repeat, body under tension usually stretch a little as the tension increases, and they return to the original length when the tension is removed, provided the tension is not too large. This property of regaining the original length is known as elasticity. The next one is thrust. If two parts of a body are being pushed towards each other, the body is under thrust. If two parts of a body are being pushed towards each other, the body is under thrust. When you are standing, your two legs are under thrust because your legs are supporting the weight of your body, which is acting downwards, while the floor is pushing upwards on your feet. Other examples are the hands of a truck pusher and the legs of a table or a chair. Upthrust. An upthrust is experienced whenever a body is wholly and partially immersed in a liquid or a fluid. An upthrust is experienced whenever a body is wholly or partially immersed in a fluid. It is the upthrust of seawater that supports an ocean-going ship, just as the upthrust of water in a river supports the weight of a fully loaded canoe. This will now take us to Archimedes' principle. Archimedes' principle states that when a body is wholly or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. I repeat, when a body is wholly or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. Flotation. As more of the body is immersed in a fluid, the upthrust will also increase. This we have the law of flotation, which says that when a body floats in a fluid, the weight of fluid displaced is equal to the weight of the floating body. Law of flotation states that when a body floats in a fluid, the weight of fluid displaced is equal to the weight of the floating body. This law may again be verified by using a displacement vessel. Another type of force is called reaction. When you exert a force by carrying a load, such as a table or chair, with your hands, you can feel a force exerted on your hands by the load. A book resting on a table is exerting a force equal to its weight on the table, and the table is though exerting a force on the book. So this is called reaction. This will take us to Newton's third law of motion. Newton's third law of motion says that to every action there is an equal and opposite reaction. I repeat, Newton's third law of motion states that to every action there is an equal and opposite reaction. The next one is friction. Friction force always acts along the surface in contact in a direction to oppose motion. So friction is that force that opposes motion. It opposes motion. It works in the opposite direction. So friction always acts in such a direction that it opposes motion. Until motion takes place, the frictional force is always equal to the force tending to produce motion. When motion takes place, the friction force is less than its limiting value. The limiting frictional force is independent of the area of contact on the surface. Friction reduces the efficiency of meshing, and it can be reduced by using lubricating oil and ball bearing and rollers. All this reduces friction in a body. The next type of force is viscosity. Viscosity is due to the friction or frictional force between one layer of liquid and the adjacent one. Viscosity is due to the frictional force existing between one layer of fluid or liquid and the adjacent one. The viscosity of a liquid rapidly decreases as temperature increases. The viscosity of a liquid rapidly decreases as the temperature increases. Viscosity of a liquid rapidly decreases as the temperature increases. The next we're going to discuss is molecular force. Molecular force. These are forces of attraction which exist between molecules of matters. These are forces of attraction which exist between molecules of matters. Sometimes we are concerned with forces of attraction between molecules of the same substance, and sometimes with those between molecules of different substance. The strong force of attraction between molecules of a substance are responsible for the strength, rigidity, and the elasticity of the solid. The force of cohesion is the attractive force between molecules of the same substance. We call it the force of cohesion. The force of cohesion is the attractive force between molecules of the same substance, while the force of adhesion, the force of adhesion is the attractive force between molecules of different substance. I repeat, the force of cohesion is the attractive force between molecules of the same substance, while the force of adhesion is the attractive force between molecules of different substance. Now I want to consider a simple calculation. And the question is this, I'll read it slowly. A solid of mass 1 kg suspended by a string is completely immersed in water. If the tension in the string is 5 Newton, calculates 1. the upthrust on the solid, 2. the volume of the solid, and 3. its density. I repeat the question again. A solid of mass 1 kg suspended by a string is completely immersed in water. If the tension in the string is 5 Newton, calculate 1. the upthrust on the solid, 2. the volume of the solid, and 3. the density of the solid. And these parameters are given. Take G, which is the gravitational force, as 9.78 meter per seconds, and density of water to be 10 raised to the power 3 kg meter per cube. So those are given parameters. Now, the mass of the solid we are talking about, which is m, is 1 kg. Acceleration of free fall, that is gravitational force, G, is 9.78 meter per seconds. The weight of the solid will be mass times the gravity, which is 1 times 9.78, and that will give us 9.78 Newton. The tension in the string from the question, which is T, is 5 Newton. Tension in the string is 5 Newton. Density of water is 10 raised to the power 3 kilogram per meter cube. That is what we can extract from that question. Now, let's calculate the upthrust on the solid now. Upthrust will be mass times gravity minus tension. Upthrust will be mass times gravity minus tension. We have calculated the mass and gravity to be 9.78 Newton, and we subtract the tension from it, which is 5 Newton, and we now have 4.78 Newtons, which is approximately 4.8 Newtons. I repeat that question again. Calculating upthrust of the solid, the formula is mass times gravity minus tension. We have calculated our gravity, our mass and gravity, which is 9.78. We deduct the tension from it, which is 5 Newton. And when this is done, we'll be left with 4.78 Newtons, which is approximately 4.8 Newton. So that is the upthrust on the body. So by the Archimedes principle, the weight of water displaced equals to the upthrust on the body of the solid. The weight of water displaced equals to the upthrust on the solid. So we have a mass of water displaced. Mass of water displaced will be weight over gravity. Weight over gravity. Weight over gravity. And that will be 4.78 over 9.78, and that will give us 0.489 kilogram. So that is the mass of water displaced. Mass of water displaced, which we have said that is the weight over gravitational force. That is the upthrust we have calculated, which is the weight over the gravitational force. So from our calculation, the mass of water displaced will be 4.78 Newton all over 9.78 millimeter per seconds, which is the gravitational force, and that will give us 0.489 kilogram. So that is the mass of water displaced. Now the second question says volume of water displaced. Volume of water displaced. So what we have calculated now will help us to really get the volume of water displaced. Since we know volume is mass over density. Volume is mass over density. We have calculated the mass of water displaced there to be 0.489 kilogram. And from the question we are given the density. We have given the density of the water to be 10 raised to the power 3 kilogram per meter square. So here the volume of water displaced now will be mass calculator, the mass of water displaced over density, which is 0.489 kilogram over 10 raised to the power 3 kilogram per meter cube, and that will give us 4.89 times 10 raised to power minus 4 meter cube. So that is the volume of water displaced. So since solid is completely in mass, the volume is also will be 4.9 times 10 raised to power 10 raised to power minus 4 meter per second cube. Now the third question is density of the solid. Density of the solid will be mass over volume. Mass over volume. The mass from the question is 1 kg. The mass of the solid is 1 kg, and the volume, as we have calculated, is 4.9 times 10 raised to power 4 meter cube. So our mass, which is 1 over 4.9 times 10 raised to power minus 4, and that will amount to 2.0 times 10 raised to power 3 kilogram per meter cube. So that is the density of the solid. So that's the density of the solid. So we're stopping here for now. Thank you.